Hi, 7th graders. Today we're going to be talking about compound events in probability. So just a quick little reminder, probability is the likelihood of an event happening, and so we can express it as a number between 0 and 1 as a fraction, a decimal, or a percent. So when what we've looked at so far is just called simple events. So that would be one event happening. So maybe you roll one dice or you spin a spinner and you're figuring out a probability based off of that. When we talk about compound events, we're actually talking about two or more events. And so there's two types of compound events. There's something called independent events and then dependent events. So independent events, if you think of what the word independent means, kind of standing alone by yourself, you can do it on your own. Independent events are where the occurrence of one event does not affect the likelihood of the next event occurring. So some examples of this would be like if we have just two completely separate events. So if we're rolling a number cube and flipping a coin and trying to figure out the probability of some specific events happening there, if we were flipping a coin and spinning a spinner, those are just independent events. So the number cube is not affecting the results of when you flip the coin. If you're looking at flipping a coin and spinning a spinner, that coin flip does not affect your spinner results. So those are just independent events. They can stand alone too. Another example of independent events would be like having a bag of marbles or a collection of something, pulling a marble out, and then the key thing here is if you put it back in before the next draw. So essentially you're resetting that bag of marbles, and so the probability of that second event is not affected by whatever. It doesn't matter what you pulled first. Your probability of that second event is not affected. So we're going to look at a couple of different examples here. So if we had 10 cards numbered 1 through 10, and I'm going to just kind of write the numbers 1 through 10 over here really quick. All right, find the probability that you draw a 2, put it back, and then draw a 5. So what we actually want to do here is we want to find the probability of a 2 and then the probability of a 5. So we're going to look at these two separate events. And so if I look right now, my probability of drawing a 2, if I were to take my 2 out, okay, or the probability of drawing that 2 would be 1 out of 10. And then it says I put it back. Okay, so now it's back in the collection. Oops. And so now the probability that I would draw a 5, I have 1 5 out of the 10. So my probability of drawing a 5 is 1/10. Okay, and so here to figure out the probability of those two events happening together, what we're actually going to be doing here is multiplying those two probabilities. So I'm going to end up multiplying 1/10 times 1/10. When we multiply fractions, we're just multiplying straight across. So 1 times 1 is 1, 10 times 10 is 100. So I have a 1 out of 100 chance of randomly drawing a 2, putting it back, and then randomly drawing a 5. Here's another example. Find the probability that we draw a 4, we replace it, then draw an even number. So again, a key phrase here that's telling us these are independent events is that replacing it. Okay, so I'm resetting my cards before I make that second draw. So I want to figure out the probability that I would get a 4, and then the probability that I'm going to get an even number after that, after I put back the 4. And this notation that I'm using here, this capital P and then in parentheses the numbers, this is just another way that you might see the probability. Okay, so P stands for probability of, and then the event here is in the parentheses. So the probability of getting a 2, or down here, the probability of getting a 4, and the probability of getting an even number. So I'm going to look at the probability, my chances of pulling a 4 randomly from that collection. I have 1 favorable outcome out of the 10. And then it says that I'm going to draw it. And then again, key phrase, replace it. So I take the 4, I put it back in, okay? And then now the probability that I would draw an even number. So out of my cards that I have here, I have 2, 4, 6, 8, and 10. So I have 5 tenths, okay, chance of getting an even number. I also know that that's going to simplify to 1/2. So I'm going to go ahead and simplify that, okay? And so again, to figure out the probability of those two events happening together, we're going to end up multiplying them. So I'm going to multiply, I've simplified the 5 tenths to 1/2. So 1 times 1 is 1, 10 times 2 is 20. So I have a 1 out of 20 chance of those events happening together. Let's look at one more example here. You draw a marble, replace it, then draw another marble. So key term and key phrase that's telling me that this is independent is that I'm replacing the marble. So again, I'm resetting the bag before I make that second draw. So I want to know the probability of choosing blue and then green. So I want the probability of blue and the probability of choosing green. Ooh, too many E's. All right, so the probability that I get a blue, I have 3 favorable outcomes. Okay, 3 blue marbles. All right, out of, if I count out my possible outcomes, I have 9 possible outcomes here. So I have a 3 out of 9 chance of drawing blue. And then my probability of drawing green, okay, so I take a blue, and then it says I'm replacing it back in. So then now my probability of pulling a green is also going to be, I have 3 green marbles out of the 9. So I have 3/9 there, and I'm going to end up multiplying these probabilities. If you can simplify a probability, it's best to simplify it. So when I look at 3/9, I realize that 3 is a common factor of both of those. So 3/9 will simplify to 1/3. This 3/9 also simplifies to 1/3. And so now when I multiply across, 1 times 1 is 1, 3 times 3 is 9. So I have a 1 in 9 chance of drawing a blue, replacing it, and then drawing a green marble.